This is question number 4 from the 4.5 MyLab math homework on absolute maximums and absolute minimums. So we're being asked to find both of those, the absolute maximum and the absolute minimum for this function over 2 different intervals. Okay, so we're given a test in section 4.5. And that test helped us avoid creating sign charts, which we can do. They're just very time consuming. So we had this theorem that said, if you're looking at a continuous function, which this is because it's quadratic, it's a U-shaped graph, it's opening up, there's no jumps or asymptotes or anything. If we're looking at that over a closed interval, so we're like chopping the domain and we're looking at that continuous function over a closed interval, then there has to be an absolute minimum and an absolute maximum in that interval. And those absolute mins and maxes can either happen at the endpoints or at a local extrema. Okay, so those are the only points we have to consider. And we know the endpoints. The endpoints are x equals 4 and x equals 5 in this case. So we're restricting the domain pretty tight there. But we need to know, is there a critical value that happens to fall in that domain? So to find a critical value, you set your derivative either equal to 0 or you set the derivative undefined. But since our original function is a polynomial, it's a quadratic function, we know it's always defined. So I'm just going to find my derivative and I'm going to set it equal to 0. So the original function is 2x squared plus 8, just using my power rule there, where x is a plain old variable. I'm going to get 4x plus 0, which is just 4x. And the only time 4x can equal to 0 is if x is 0. If I need to, I can divide both sides by 4, and I can see that x equals 0 divided by 4, which is just 0. Oops, there we go. So this is my critical value. Critical value. If I plug that input back into my derivative, I'm going to get 4 times 0 is 0. So how I get a 0 out? So I know when x equals 0, I'm going to have a horizontal tangent line there. Now the problem is that x value is not in the given domain up there. 0 is not between 4 and 5. So I'm not considering that critical value. So the maximum and minimum, the absolute maximum and minimum, have to happen at those endpoints. So I'm just going to plug 4 into my function, my original function, to locate that point on the graph. How high or low did it go? Let's plug it in. We'll see what our calculator gives us. Okay, I get 40. Then I'm going to plug the other endpoint into the function. So 2 times 5 squared plus 8. That'll give us 58. And again, I'm not going to plug the critical value into the function because the critical value is not in that domain that I'm considering for part A. So for part A, 40 is going to be the absolute minimum and 58 is going to be the absolute max. Okay, but now on B, my domain is different. On B, I'm going from -5 to 5. So come back and look at that critical value. Is 0 in the domain, woo, -5 to 5? It is, right? 0 is just smack dab in the middle of that. So in this case, I'm going to consider the endpoints. I'm going to plug -5 into the function. I'm going to plug +5 into the function. And I'm also going to plug that critical value because it's between -5 and +5. So I already know when I put a +5 in the function, I get a 58. Let's find these other two. So I'm going to plug a -5 into the original function. And when I do, I get a 58 out. And then I'm going to plug a 0 into the original function. And when I do, I get an 8 out. So these are the only 3 outputs I'm going to consider as my contenders for absolute extrema. So 8 is the smallest, so that's going to be my absolute min. But then there's a tie for my absolute max. Okay, so there's just 2 inputs that create that absolute maximum output of 58. So I'm going to have an absolute max. There's only one absolute max. The absolute max is 58, but it happens 2 times. So I'm going to say there's an absolute max of 58 when x equals -5 and again when x equals positive 5. And if you want, you can graph this original function on Desmos. Desmos will not be allowed on test 3, but it's totally allowed for as a learning tool while you're doing your homework. So put that, quadratic function there into Desmos. Look at those restrict the domain if you want, or just kind of zoom in on the graph between -5 and 5 and look at the outputs. What's the highest point on the graph over that domain? What's the lowest point on the graph over that domain? You can use Desmos as a learning tool. Just wean yourself off of it because you will not be allowed to use Desmos or a graphing calculator on test 3.